Hey, welcome back to Better Through Tech. Today we're going to be looking at LEDs and the difference between syncing and sourcing them and the code that it takes to run them. Once we're done with this section, we'll be looking at RGB LEDs, the common anode and common cathode, and using the code we have here to make them work. And once we're done with that, we'll be looking at our first for loop and what it takes to get that to work, and we'll be applying that to our RGB LED and to get it to change colors. Now, with that being said, let's jump right into it. Get into our Arduino IDE, and we'll create ourselves some space up here at the very top, and let's give ourselves some variables. So we're going to call the first one LED 1, and we're going to connect that to pin 2. Then we're going to go LED 2 and connect that to pin 4. Once you have completed that, we're going to come down in here to setup, and we are going to tell the Arduino how to handle these. So pin mode, we're going to go LED 1, and we're going to say output. And then we're going to repeat the process, and we're going to go LED 2, and we're also going to say output. Once that's done, we're going to come down into our loop, and we're going to use one of our key command words called digital write, and we are going to set that up. LED 1. Oh. I'll get it right one of these days. And then we are going to say hi. And then we'll just repeat that process again. Digital write. I'll get it right here. 2. And then we are also going to give that the condition of hi. Now, with that being done, let's jump over here onto Tinkercad and we'll see how this is set up. And as you can tell, these are very similarly set. The main difference is where the resistor's at and how the Arduino reacts with that setup. On pin number 4, you can see this is set up just like we did last week, how we had it set up just last week. If you tore it apart, no big deal. Here it is again. It just pulls it down. When you give it to high command, it feeds it down in through the anode side, lights up the LED, and then it feeds the energy through the resistor and sends it to ground, and out it goes. Now, when you're syncing it, it works a little differently. When you're syncing it, it actually comes from the power, goes through the resistor, which then goes to the anode, through the LED, which then goes to the cathode, and then gets then it syncs into the Arduino. So it's just a direction of flow, and the commands actually get reversed. It's a little counterintuitive at first. It's kind of one of the reasons why I suggested using the on-off commands, because when you start working with syncing and sourcing, how you turn them on is a little differently, and it can be a tad confusing if you forget how you have it set up. And as you start getting into LED matrices, Charlie plexing, that kind of stuff, a lot of companies will use common anode setups. And so what turns them on will be the opposite of what we would probably normally use here. Neither one of them is necessarily right. Neither one of them is necessarily wrong. You're just going to have to do what feels more comfortable to you, and just make sure to just stick with it. Once you're done, we are going to go up into here. We're going to connect our Arduino, and we are going to make sure we're recording on our camera, else we are not going to be able to see what is going on here. And then once we hit upload, we'll let it do its thing. And what did I do? We have an error, and I put the I in the wrong spot. I do that a lot, and I'm really good at doing it. Let's try this again. Consistency. That's the big thing about programming. Always make sure you stick with it. But once it's done, all right, now you can see only one of the LEDs lit up. Why is that? I kind of discussed it a little bit ago when we were on the Tinkercad. When you are syncing, the LED has to be pulled one direction, and when you're sourcing, the other LED has to be pulled the other way. So what do we got? This red one here is lit up. That is pin 4, so that's our normally hooked up one. So if we go over to where pin 2 is at, you can find pin 2. So that's LED 1. Like I said, it can get a little confusing if you're not really on point with this. So that's why I double clicked on it. So I'll highlight everything that's been named LED 1. It makes it a lot easier to find stuff. So then we'll come back down here We'll actually change this to low. Now, let's try it again. See what happens when we upload it again. We get it reading its information. Oh, look at that. Now we have both of them that are on. Isn't that great? A little confusing, because technically you're pulling information, pulling it low on one side and pulling it high on the other. So, now we have both of the LEDs on with two different feeds. Now, if we do this, kind of just a little something to play with, we can pull both of them high, and then we'll just give it a little delay, and we will copy this whole thing. We're going to right click and we're going to copy, and then we're going to paste, and then we'll just pull both of these low. Yeah, there we go. Now pull both of these low. Now, one will just do the opposite of the other, and now you can give yourself a little, I don't know if you're into trains or not, but you can give yourself some railroad lights. Very simple way of doing that. But yeah, so now that we got that figured out, let me take a break here and let's get our RGB set up here, and we will continue on with the video. Alright, real quick before we jump into Tinkercad and I explain how to wire this up, I wanted to show you the legs on the LED real quick, because since this obviously is very much different from a standard LED. Standard LEDs will only come in one color, unless they have a built-in chip in them that will do some auto stuff for you. Those are cool and all, but it's a lot better to have these because you can do with them what you want. Now these, you'll see this has got 4 legs, because this has got a red, green, and blue LED inside of them, thus the whole RGB name. Let me flip this around for you, because I think this is how it's going to pop up for you on the screen. Now these 4 legs is what it'll look like. This long leg, regardless if it's common anode or common cathode, will always be your primary leg for usage. So if it's common anode like this one is, this is where the positive rail is going to be. If it's a common cathode, this is where the negative rail is going to be. Now the first leg to the left is going to be the red LED. The first leg to the right of the common rail is going to be green, and the last one on the furthest right side is going to be the blue LED. They're always wired up the same, regardless if it's common cathode or common anode, like I had mentioned. The only thing it'll be different is just the center leg. So, yeah, so there it is. Now, let's go ahead and get into our Tinkercad, and we'll show you how to get this wired up so we can use it. Alright, now that I have this set up, I got the RGB LED set up, we're going to immediately start off here in the Tinkercad file, so that way you can see exactly how it's wired up. And again, if you remember, this is going to be a common anode LED, so we're going to wire this up a little differently than a common cathode LED. So this time we're going to be hooking up our 100 ohm resistor to the second leg in from the left, which as you can see right here says cathode. That's going to go to the positive rail, which then is going to go to the 5 volts. And these are color code correct. This one right here we're going to use at pin 3, which is going to go to the first leg of the LED. Then on pin 5, it's going to be the green color. We're going to set that up on the third leg, and then on pin 6, that's going to be the blue leg of the LED, and that's the last leg. So now that we got that out of the way here, let's jump immediately into here onto our Arduino, and let's start programming, shall we? So let's create some space up here, right? Let's create our global variables like last time. So we're going to go int, as always, because we're going to stick with the int variables for right now. So we're going to go red LED. We're going to use some of that good old camel casing on pin 3. And we're going to go int with green LED, right, on pin 5. And then int one more time for blue LED. And that's going to be on pin 6. If you've noticed what I've been doing, if you look on your Arduino, holy cow, I cannot get that straight. If you look at your Arduino, you'll notice there's a bunch of tildes, and yes, that's actually what they're called. you'll see on here there's a bunch of little tildes on here. Any of those pins have the ability to do pulse width modulation. So in this case, we're using pins 3, 5, and 6, but you also have access to 9, 10, and 11. If you're using like an Arduino Mega, that one has got a lot of pulse width modulated pins on it. And then I do believe if you're using anything with the ESP pin or ESP board, any of the pins on there I do believe are pulse width modulated. So you have a huge variety of setup there. But for the Uno, we only have 6 pins. So what we're going to do, remember, we're going to tab in once because we are inside a set of curly brackets. We're going to pin mode, right, with a little bit of camel casing and curved brackets. And we're going to go red LED. And remember, it's going to be an output, right? So let's save ourselves a little bit of time. We're going to hit Control-C to copy this. Enter, Control-V, enter, Control-V. We're going to paste ourselves 2 more lines here. Then we're going to go green and blue. And there's our outputs. Next, we are actually going to skip void loop. Remember, we discussed this. We are going to work on building some functions. So this is going to be the first program we're going to dedicate on to build our function out. So since we're not returning, again, I'll show you what that looks like when you're returning something, just so you can see it. But we're not going to use that, so it's going to be void. And let's stay on point here. We're using what? An RGB LED. So we're going to call it an RGB. Curved brackets, then we're going to go int red, comma, int green, comma, and int what? Blue, right? Curly brackets, tab in, and then this is where all of our commands are going to take place. So what are those commands? Digital write. This is where all of our lifting is going to take place. This is where everything's going to get switched on and off at. So we're going to go red LED, comma, what? Red, right? We're going to call that red. And then we're just going to repeat the process for the other 2 legs. So let's do that quick copy and pasting again real quick here. And we'll get those put in. Put the green in there. Green again, right? Blue and blue. So what does this do? What this is going to do, if you click on any of these names here, they will show you what else they're connected to. So in this case, red LED and red. So red LED is going to call pin 3, right? Because that's an output. We're going to send information out to it. Red is going to pull information from here. How do we get that information sent? Just like this, RGB curved brackets. And remember, because this is an anode, we have to flip our states. So this isn't going to we're not going to be using 255 to pull it on, or pull it high. We're going to use 255 to pull it low or turn it off. So what does that mean in our case? We have to use 0 to turn on this LED. So we're going to use 0, 255, comma, 255. And what does that mean? That is our red LED. If this was a common cathode, these would be flipped. This first leg would represent red, the second one would represent green, and this third set would represent blue, right? Okay, so go down. We're going to put a 1,000 millisecond delay on there, 1 second. We're going to call RGB again, and we're going to go 255 this time on the first leg or first section of this, because we're going to be turning it off. We're going to hit 0 because we're going to be turning it on, and then 255 again, and a delay one more time, right? And then RGB again. This time we're going to go 255, 255, 0. This is going to turn on our blue LED, blue side of our RGB LED, right? And I'll put green right there too. And let's go down one more time. We're going to put a delay right there. So what this should do is it should show us our red, green, and blue values, right? So we're going to go up here, we're going to select our Uno, and we're going to hit upload. And with any luck, oh, we got ourselves some errors because I forgot how to spell. Most of you people in the world of YouTube are probably laughing at me right now because you probably spotted that a while ago. But again, so there we go. We got ourselves red, green, and blue. And then, so yeah, so there it is. So what happens when you actually wire this up the wrong way around? So let's say you wire this up as a common cathode and not paying attention to its values. You might end up with something like this. Depending. You will start getting weird readings. Something like this. So now that I flipped all the values around, we'll re-upload this again, and then you'll see that you will start getting some weird readings. You get like a bluish teal color, you get pink and yellow. Those are not at all red, green, and blue, right? So if you accidentally hook this up as a common cathode, this might be something you could potentially end up seeing. So just so you know, if this ends up happening, this is how you're going to know that this is actually a common anode LED and not a common cathode. So let's go ahead and hit Control Z to backspace this because I don't want to type all this out again. We'll get all those set back up. So what happens if you want to see some other colors? Well, I have a website open just for that specific reason. You can pick any color in the spectrum that fits the RGB values. And you notice that 255 is stuff that we use in the code that we're working on, right? So I have this one specifically selected out. What is this? Laser Lemon? It's yellow. I don't know why they gotta be fancy about it. Essentially, it's a yellow color, right? It says 255, 255, 25. Well, since we're using a common anode, we can't use those values because from our perspective, we have to flip it to the other end. So what does that mean for us? It's going to be 0, 0, and 230 because we have to flip the values to the other end of the spectrum that they would be on because, again, we're using a common anode LED. If you're using a common cathode LED, this would be right. You could just use it straight up. But, again, we're not, so we can't. But this time, RGB, we're going to say what? 0, 0, and what was it? 230. So, and then we'll hit delay and 1,000 seconds. And let's go ahead and upload this and see what happens. We should get all of our normal colors back, and then we should get yellow in there. So red, green, blue, and there's our yellow. All right. Let's try one more. Let's pick something... pick something over here. I'm not going to get into the crazy names they got. What was this? Purple Pizzazz. So let's try this one. So what does it say? 255, 51, 255. So what is that going to be? That's going to be 0, right? It's going to be 0 and what? 204 and 0. So let's go ahead and go in there and we'll add that to our lineup. So again, RGB. And we're going to go, what, 0, comma, what was it, 204, comma, and 0 to flip the values around. We'll give it that semicolon to close out the line, and delay for 1,000 milliseconds, and let's go ahead and upload again, see what we get here. And if we go through this, red, green, blue, we get our yellow, and then there's our purple. Hey, look at that, awesome. We have got a color spectrum set up. That is so cool, right? Feel free to add any of these colors you want. You don't have to use the ones that I picked. You can pick any of them. You can add as many in there in this lineup as you want. Go have fun. Check out some colors. There's some really cool colors in there to see. Next, let's Let's add a button to this. It's cool to watch the color cycle, but how cool would it be if you had control of what colors were staying on? What happens if maybe if you just wanted red and you just wanted to stay there? Or maybe you wanted that blue or purple to turn on and just stay there. Let's give the user more control over the program and let them pick the color they want. So let's give it a temporary pause real quick and let's get that set up, and I'll be right back.